So we will start in about 2 or 3 more minutes. Let's wait for few more people to join, then we will start. Okay? Okay, so maybe we will get started. When we have waited enough. Okay, so hello, namaste, and welcome everyone. Welcome to this problem solving session. The recording is already started. Yeah. Uh, just a second. Let me just see. Mhm. Okay. Good. The iPad is connected and we're, we're good to go. Okay, so I hope the screen is visible, right? Uh, so sorry. Okay, so this is going to be week 8. We are going to solve problems related to pertaining to week 8. Okay, and week 8 was all about what F distribution, and descriptive statistics. Right, so we will be solving problems pertaining to these two things, right? But before that, I would like to like give some overview of what F distribution is, and like, yeah, like all the things, its certain properties that we are going to need today and all those stuff. Okay, okay. So yeah, this is fine. Recording is happening, right? Yeah. So maybe I will start by first introducing few of the key distributions that we will keep seeing often. Okay, uh, in the upcoming weeks. So the first distribution, we will write some uh, recurring uh, distributions. Okay, so the first one is students T distribution. Okay. What is students list distribution? It is a distribution which whose PDF looks like this. So f of t is equal to gamma nu plus 1 by 2 over root over pi nu gamma nu by 2, right? Into 1 plus t square by nu into minus nu plus 1 by 2, right? Where, and what is new here? New here is the degree of freedom. So this is one of the like recurring distributions that we'll keep seeing, right? Then the other distribution is what we call, so just a second. Yeah. So the other distribution that is kind of going to be important to us is the chi-square distribution, right? What is the PDF for the chi-square distribution? Chi-square distribution f of x is equal to, it is only defined for x greater than 0, okay? Otherwise, it is 0, right? And if it is not 0, if it is greater than 0, what is it? It's x raised to k by 2 minus 1 into e raised to minus x by 2 whole divided by 2 raised to k by 2 gamma of k by 2. X is greater than. This is your chi-square distribution. Again, something which we will keep encountering in the upcoming lectures. And the third one, which was sort of related to this week's uh, uh, this week's content basically was the F distribution, right? So what is the F distribution? Okay, by the way, here in the chi-square distribution, uh, uh, K, okay, I forgot to mention this thing that here K, this is the degree of freedom. Okay, and for F distribution, your this thing, the PDF is given by again this weird looking distribution. F of x is equal to 1 over beta of d1 by 2 comma d2 by 2 d1 by d2 whole raised to d1 by 2 d1 by 2 x raised to d1 by 2 minus 1 into 1 plus d1 by d2 x whole, okay, bringing out of space, d1 minus d1 plus d2 by 2. This is the F distribution, and here uh, uh, okay, I mean uh, so d1 and d2 are here positive integers, are here positive integers, okay. What else? Okay, maybe I will explain what d1 d2 is in more detail, but yeah, these are the three distributions that are sort of like the most important distributions for us in the upcoming uh, lectures or the week to come, right? Because all the tests that we will see and that will be taught will be based on these distributions. So t distribution, chi-square tests, and stuff like that. All of those things will be based on these things, right? So yeah, it's better to just keep all these things in at the back of your mind. So let's discuss few things. Like I want to first tell some properties about F distribution, and then we will go to your problems to solve. Okay. So okay. So first of all, how do you obtain a random variable of F distribution? So okay, so this is how you go. So basically, how to sample from F distribution. This is the question. And change the color of this one. So the answer to this is as follows. Okay. So uh, so let's say it's so the two parameters d1 and d2, right? So you want to sample from f of x with parameters d1 and d2. What you do is the first step is sample sample d1 plus d2 standard normal random variables. Okay, standard normal is normal 0 1, right? You sample d1 plus d2 of them, okay, from the standard normal distribution. Okay, then second step is like you take the first d1 of these things, first d1 of this. So this will give you xi I going from 1 to d1 plus d2, right? And where, uh, yeah, so where xi are sampled IID from what? Normal 0, comma 1. This is how you get all you get this set of random variables, right? Then what you do is you construct u1, which is equal to what? It is equal to summation of xi squares. I goes from 1 to d1. Okay. So basically, uh, you take the first d1 of the standard. So there are d1 plus d2 random variables. You take the first d1 random variables, square them, and just add it. You get u1. Okay. Then what you do is you take you find d2, which is what? This is again summation xj square. Now j here is going from d1 plus 1 to d2. Okay. So it's like now you take the next, so there were d1 plus d2 random variables. You took the first d1 of them, squared them, and added them. You obtained your u1. Okay. Now you take the remaining ones. So the d2 random variable, remaining d2 random variables, again square them and add it. You get u2. Okay. Now if you remember from our last class, so u1 here. So I mean, you should always, whenever you see squares of random variable being added, the first thing that should come to your mind sort of is that u1 is distributed according to what? It is distributed according to chi-square distribution. Okay, with parameter what? The parameter is the number of random variables that you are adding, d1. So the degree of freedom of u1. So u1 is a chi-square random variable whose degree of freedom is d1. Similarly, what will be u2? U2 will be again a chi-square random variable with degree of freedom d2. Okay. So basically, you have to construct first. So first you sample these random variables, standard normal random variables. Then using these random variables, you find u1 and u2. Okay. Now, once you are done with this, then the third step is you find x, which is nothing but u1 by d1 divided by u2 by d2. Okay. So, and if you do this, then x is actually distributed according to f distribution with parameters d1, comma d2. So maybe have a look at this. So this is how you construct uh, uh, basically this is how you construct a random variable sampled from f distribution, so to say. Uh, So, right, this is how you, so I mean, like you should know how to, construct these random variables. Otherwise, just knowing the definition of them won't help you as such. And when you're constructing it, you always start from something which is very simple. And what is very simple is standard normal random variables, right? It is easy to sample from this distribution. You do this operation, construct chi-square random variables from them, then divide the scaled version of these chi-square random variables to obtain the final desired random variable, which is distributed according to f distribution. Okay, okay. So moving on, what I will do is I will write few properties of f distribution just to make just to like I want to just put it out there so that you know uh, we can solve the problems easily, bit easily. We will just use these properties to solve the problems on F distribution. Then descriptive statistics is more or less very easy. That won't take a lot of time. Okay. So yeah. Okay. So let me write down few properties of F distribution. Okay. So here it is. Um, the properties of F. distribution. So here, let's start with the first property, right? The first property is that, I mean, it's just the definition. By I will just write down. So if X is sampled from a chi-square distribution with degree of freedom d1, and Y is sampled from chi-square distribution with degree of freedom d2, right? And are independent, independent, uh, then X by d1 divided by y by d2. This is sampled. This is distributed according to F distribution with degree of with parameters d1 and d2. This is just by construction, right? So from these steps, you can see that u1 was actually chi-square distributed and u2 was also chi-square distributed. You divide them with their respective degree of freedom, and like again, like just take this ratio. What you get is a F distribution random variable. Okay. So this was just by definition. So just to something to remember. Okay. Okay. The second thing is, uh, maybe I will just write it down. So if xk is a random variable which is distributed according to gamma distribution. Okay. Gamma distribution with parameters alpha k and beta k, right? For the k is equal to 1 and 2. So there are two random variables x1, x2, which are distributed according to gamma distribution with parameters alpha 1, beta 1, and alpha 2, beta 2 respectively. Uh, okay, and are independent. So I will use this sign to indicate independence. Then uh, alpha 2, beta 1, x1 by alpha 1, beta 2, x2. This thing is distributed according to another again F distribution with parameters 2 alpha 1 and 2 alpha 2. Okay. So you take two random variables from gamma distribution. The gamma distributions can be with different parameters, and then you take this ratio. This new random variable is will be distributed according to F distribution with these 2 alpha 1 and 2 alpha 2 as the parameters, right? Uh, this was with gamma distribution, but again, you can again construct uh, this F distribution random variables from other distributions. For example, you can use beta distribution, right? So if X is sampled from beta beta distribution with parameters d1 by 2 comma d2 by 2, right? Then what? Then d2x over d1 into 1 minus x, this random variable will be distributed according to F distribution with parameters d1 comma d2, right? So you can see, right, that you can construct this random variable from other simple random variables, chi-square, gamma, beta. So yeah, I mean these are some properties that you can it's good to remember maybe. Okay. So So, like, so here we went, so this property told us how to construct a F distribution random variable from beta distribution, right? Can we construct a beta distribution random variable from F distribution? Is that thing possible? Well, yes, it is possible. So let's say if X is sampled from F distribution with parameters d1 comma d2, right? Then uh, then d1x by d2 divided by 1 plus d1x by d2. This thing is distributed according to beta distribution with parameters d1 by 2, d2 by 2. Okay. Okay. Let's look at some other distributions of F distribution now. Okay. Uh, so let's look at this fifth property. So if X is distributed according to F d1 comma d2, okay, if this is the case, then d1 by d2 times X, this thing is distributed according to beta prime. So there's a beta prime distribution with parameters d1 by 2 comma d2 by 2. This is another property of F distribution, right? So if you take the ratio of the parameters d1, d2 multiplied with x, you get a sample from this beta prime distribution. Okay. Now, uh, what else? Well, this property is interesting. So this property is sometimes used. So right. So sixth property is that. So let's say if x is distributed according to f d1 comma d2. Okay. Then the property says that 1 by x, which is equal to x inverse, this thing is also distributed according to f distribution. However, the parameters are now reversed. So this is d2 comma d. Okay. So like it's like saying that if x was constructed by taking this ratio u1 by d1 over u2 by d2, right? This implies that 1 by x will be what? u2 by d2 over u1 by d1. Now, if you look at it, u1 and u2 were independent, right? It's just that the parameters are now reversed. So this thing will now be distributed according to f of d2 comma d1, and this thing was distributed according to f of d1 comma d2. So this is how like this taking inverse will like change the order of the parameter. That's all. Wait. Okay. Uh, okay. So another property is this that seventh property that that if X is distributed according to student's t distribution with degree of freedom n, right? Then then x square is actually distributed according to f distribution with parameters 1 comma n. And similarly, if you take inverse of it, x raised to minus 2, this thing will be distributed according to what? The parameters get reversed, right? So f of n comma 1. So yeah, I mean these are some of the properties of F distribution which are like very helpful in like solving problems and like yeah could be very handy. That's all. Okay, so let's now solve some problems. Okay, uh, so I think there is something in chat. So yeah, this problem that you have sent, I will solve that problem. Just let's solve this problem first, okay? If you want, but yeah, I mean, if you just post something on chat, I won't be able to know that it is there in chat. You need to speak up, okay? Otherwise, it's totally possible that I will miss it out and I will just proceed. So it's better to just say that I want this you to solve this problem. Anyways, uh, okay. So let us look at the first problem. So it is given to us that x1, x2 till xn, these are IID, normal mu comma sigma square. Okay, and it is given to us that x bar is equal to 1 by m summation xi. I going from 1 to n, and s square is equal to 1 over n minus 1 summation xi minus x bar whole square I going from 1 to n. And there are four statements that are given to you. The first statement is x bar is so x bar is distributed according to normal mu comma sigma square by n, right? B option is s square follows chi square distribution with degree of freedom n. C option is that x bar and s square are independent, and D option is that n minus 1 s square over sigma square. This thing follows a chi-square distribution with degree of freedom n minus 1. So these are the statements. After this, we will solve the other question that you have sent on chat. Okay. So which one of these is true? So the first, uh, uh, okay. Anyways, so these are actually standard statements. Basically, you just need to sort of uh, remember. If you remember the properties, you will know. Since see x bar is what? It is just the sum of, it is this summation of xi, right? This is what x bar is. So now xi are a normal mu sigma square, right? So since it is a affine transformation, or it's just a linear combination of normal random variables, this means that x bar will follow normal distribution only, right? However, the thing is, what is the mu and sigma of this normal distribution? For that, you take the expectation of x bar. It will be 1 over n summation expected value of xi, because xi's are independent. And we know that this is 1 by n summation mu. And this will become n mu by n, and this will become mu. Right? Similarly, variance of x bar, what will that become? Variance will be 1 over n square, 1 over n square summation of variance of xi, again because of independence, right? And this will become 1 by n square uh, into n times sigma square. And gets cancelled, so this is sigma square by n. So the mean is mu, and this is sigma square by n, right? Uh, now, now, if you look at s square, which is summation over, this is 1 over n minus 1 summation xi minus x bar whole square, right? So, so if you see that, this xi is a normal mu comma sigma square random variable, and this x bar is a normal mu comma sigma square by n random variable. Okay. So the difference between the two is going to be, if you subtract these two, then again the new random variable will be a normal random variable. Okay. It will be again be a normal random variable with mean. What will be the mean? Just you can look at this and say that the mean will be 0. And what will be the sigma? The sigma square, you will have to be a bit careful, but yeah. So I mean, maybe I will leave it as an exercise, right? So just find out what will be the sigma square. It will not be 1. Just remember that, or it won't be anything trivial, because I will maybe I'll give you a hint, right? So variance. of xi minus x bar, right? This thing will be what? Variance of xi plus variance of x bar minus 2 times covariance of xi comma x bar, right? Now this time xi and x bar, this term won't be zero because if you remember x bar is calculated by taking sums of xi's, right? So there will be some covariance between xi and x bar. You need to think. You will have to calculate this thing exactly. Okay. This variance, this is sigma square. This variance, this is sigma square by n. You find out what this covariance is, and then just substitute it. Okay. And well, I will tell you the result. S square is actually so it will since this is sum of normal random variables. However, this is not the sum of standard normal random variables. That's one thing to keep in mind because this variance, this is not equal to 1. However, then afterwards we are scaling it by 1 over n minus 1, right? And because of that, this S square, though it is a sum of n Gaussian random variables, but all of them are not standard Gaussian. And to correct this thing, correct as a measure of correction for because they are not standard, you scale them down by n minus 1, and hence S square actually follows a chi-square distribution with parameter with degree of freedom n minus 1. Okay, I mean, you could let me know if this is not clear, but yeah, I'm leaving something to you to just uh, just find out. So this I'm leaving this as some sort of exercise. You can try it out. It's a good exercise to do. So I have given you some hint. You can encash that. Okay. Also, I mean, in the lectures, it was also proved that x bar and s square are actually independent of each other. Okay, so I mean, okay, this will still be a degree of freedom will be n here. Okay, okay. Sorry, my bad. Okay. Sorry for this. The degree of freedom will be n here. Okay. So and also you can prove that x bar and s square are actually independent of each other. Okay. And uh, the other thing is that if s square is actually distributed according to chi-square with degree of freedom n, right? Then n minus 1 times n minus 1 by sigma square of s square. This thing will follow again a chi-square distribution, but with degree of freedom n minus. This is again the property of chi-square distribution basically. So if x is following chi-square distribution, right? Uh, then n minus 1 with degree of freedom n, then n minus 1 over sigma square times x. This will follow chi-square with degree of freedom n minus 1. So it's like if you want to decrease the degree of freedom of a chi-square random variable, you apply this transformation. So so all of the statements are correct. Okay, this is correct. This is correct. This is correct. Uh, uh, Wait. Oh, I think sorry. Again, sorry. This should be n minus 1 only. Right? Because this correction term is there, right? And yeah, this thing is fine. So A, C, and D are correct. However, this B option is not correct because the degree of freedom that is given to you here is n. However, the degree of freedom actually is actually n minus 1. So this is actually just based on the property of chi-square distribution. Nothing major here. Sorry, I stumbled a little bit in between. But yeah, I mean, I hope you have seen the lectures, and even in the lectures this was uh, put across. Yeah. Sorry, what? Yeah, sorry. Right. No, no. E of x square is not sigma square. Like which x? Are you talking about these x? X1, x2, x1? So sigma square, which is variance of xi, this is expected value of x square minus expected value of x whole square, right? So this is expected value of x square minus mu square. This implies expected value of x square is equal to sigma square plus mu square. So expected E of x square is not sigma square, it's sigma square plus mu square. Okay. So be careful about these things. If it is not zero mean random variable, then expected value of x square will have that additional bias. Can you repeat? Can you repeat? N into s square by, yeah, yeah. Uh, so okay, so the property is as follows. Okay, I will just erase it and write it. So the property is if x follows chi-square distribution with degree of freedom n. Okay, then what is your question? Okay, the degree of freedom is n minus 1. Fine. Then what is the question? N, you mean x, right? Okay, let's say x square. N into x square by sigma square, right? This thing. Yeah, this will follow a chi-square distribution with degree of freedom n minus 1. Is it fine? Okay, okay. Anyway, moving on to the next question. Uh, the next question is as follows, right? Okay. So suppose we have a random variable x which follows f distribution with parameters m comma n. Okay. Also, this f alpha m n is the this is the upper alpha percent point of f. What does it mean? It means that probability of x greater than f alpha m n is equal to alpha. So this thing, so f alpha mn is a scalar value, okay, such that this probability is equal to alpha, okay. And then you have been given few statements. The first statement is 1 by x follows f n comma m. Second statement says if y follows t distribution with degree of freedom n, then y square follows f distribution with degree of freedom 1 comma n. Third statement is expected value of x square exists for n greater than 4. And fourth statement is f of 1 minus alpha m n m is equal to 1 over f of alpha m n. So these are some statements that are given to you, and you have to basically find out which of these are correct and which of these are not. So few of them you can straight away tell if they are right or wrong, right? Because the first statement is correct, right? This is the property of F distribution, which we just saw here, right? That this property, that if X is following F d1 d2, then 1 by X will follow d2 d1. So here in the question it was given that X is following uh, fmn, then 1 by X will follow fnn. So that is correct. This statement, the second statement is also correct because we just saw this property that if X is following a T distribution with degree of freedom n, then X square will have this distribution, F distribution with parameters 1 comma n, right? So this is what is told here as well. So that is also correct. Now this is the third statement is actually a property of uh, uh, F distribution, right? That the even moment of F distribution exists only for when n is greater than when n is greater than 4. So this is a fact basically. Just remember it that the for F distribution, the even moments, even means x square, x raised to 4, x raised to 6, these moments only exist if the parameter n here, the first parameter, is greater than 4. Otherwise, it doesn't exist. For the fourth statement, you will have to do some solving, basically. And so let's do those solving, okay? So this is f of f1 minus alpha nm, okay? So let us look at it. So first of all, uh, for if the parameters are n comma m, then the random variable that we need to look at is 1 by x. Uh, do you agree with this? Because if x is following uh, f of m comma n, right? Yeah. So f is following m comma n, then 1 by x will follow f of n comma n. And here the order is n comma m. It's not m comma n. So we need to look at 1 by x somehow. Okay. Also, we need to look at 1 minus alpha. So let us just look at these things. So first of all, from what is given to us, this thing, right? This thing is given to us. So what is it? Probability of x greater than f of alpha m n. This is given to us to be alpha. Okay. If that is the case, then that implies that probability of we need to look at 1 by x, right? So we will just take inverse on both sides. F of 1 by x less than 1 over f of alpha m n, right? This thing is equal to alpha, right? Now, this random variable, let's call this random variable as something called v, okay? V. So v less than or uh, is then equal to 1 over f of alpha m n. This thing is alpha, right? So here v is distributed according to f of n comma n, right? The parameters are reversed. And from here we can say that probability of v greater than equal to, okay, so just a second, one mistake. This was this less than, and the I am taking now the complement, right? 1 over f of alpha and n. This thing is given to be 1 minus alpha, right? So we have come to this. Now, this implies if I call this thing as, let's say, something called C, so probability of V greater than equal to C is equal to 1 minus alpha, right? And B is distributed according to f of n comma n. So what is C? By definition, right? See, by definition, it is given to us that if m comma n is the parameter and the probability of this thing greater than x greater than the probability of x being greater than this constant is equal to alpha, then we call this constant alpha mn, right? Therefore, by definition, what should we call this thing? C here. C has to be F. It is greater. So this value is 1 minus alpha, right? And the parameters are n comma m. I hope you will agree with me on this. And this thing we just saw here, this thing is f of alpha m n, right? This implies, oh, sorry, oh, inverse of this, right? So yeah, I mean, this is what was desired, right? 1 over 1 minus alpha n m is equal to 1 over f alpha m n. So this is also true. So the last statement is also true. So all of the statements are correct. I hope I have answered the question that you had posted on the chat. Okay. So, uh, what else? Which one? For exists only for n is greater than 4. So this is a fact for f distribution, right? So the even moments. What do I mean by even moments? The expected value of x square, expected value of x raised to 4, expected value of x raised to 6, and these so on. These will exist only if n is greater than 4. This is a fact. So you need to remember this property about f distribution. Yeah. For n equal to 1 even moment, n equal to 1, 2, 3, the even moments won't exist. 1, 2, 3, it won't exist. 4 and greater than 4, it will exist. 4, 5, 6, 7, 4, all those, it will exist. Yeah. Okay, so which problem should I solve next? Uh, okay, so maybe I'll go to this question where basically you have to use descriptive statistics. Okay, let me let me solve one or two problem on that and then we will stop. So here is the third question. So x is a random variable. Okay. Uh, so okay, the question is that so let's say there are so basically there is a manufacturing company. Okay, it manufactures a lot of bulbs, and x is denoting the uh, time or time to failure of a bulb. So, so X is the random variable which tells you how much time is left for the bulb to fail. Basically, how much time does it take for the bulb to fail? That is denoted by X. Okay, and it is given to us that well expected value of X which is equal to mu. Okay, mu is given to you, and it is also given to you that the standard deviation, right? So uh, sigma basically, which is square root of variance of x, that is given to us to be 80. Okay. And so this is given to you. The question is that if failure time so what you do is you collect n such bulbs, you take n such bulbs, okay, and you check the failure time of each of these bulbs. So let's say these are let x1, x2 till xn. So You take n bulbs and you see what is the failure time of each bulb and you record it. Let's call these random variables x1, x2 till xn. Okay. So the question is smallest value, what is the smallest value of n? Okay. So that probability of uh, x bar, the average failure time, and the difference between x bar and mu less than or equal to 40. This is greater than or equal to 0.9. This is asked to you. So I will repeat the question. X denotes the failure time of a bulb, okay, and it is known that the mean is mu and the variance, the standard deviation is 80. What you do is you collect n such bulbs and look at the failure time of each of these bulbs. So you will get n random variables x1, x2 till xn. The question that is asked is what is the smallest value of n? So how many bulbs should you take so that this condition is satisfied? Here x bar is equal to 1 by n summation I equal to 1 to n. The average failure time of these n bulbs. Okay. So if the question is not clear, let me know. Okay. Uh, I will go ahead and solve this question. So if this is the question, then again, whenever you are dealing with this question, you have to go to standard normal variable. Okay, there's no other option. So it is given to you that probability of x bar minus mu less than equal to 40 is equal to 0.99. Okay, so you have to make this a standard normal random variable somehow. How do you do it? Simple, right? You just uh, basically uh, divided by the standard deviation of x bar, right? So wait. So you know that what expected value of x bar, this is equal to mu. So mu is already subtracted from this. So it's a zero mean random variable. Now you have to make the variance to be one, right? So for that, you look at the variance of x bar. Variance of x bar, what will it be? So it's 1 by n summation xi, right? So it will be 1 by what? 1 by so this will be uh, okay. So we summation of variance of xi. So summation of 80 square, right, over n square. This is what it will be, right? And this will become n times 80 square by n square. So this will become, so this is 80 square by n. So what will be the standard deviation? This sigma. This is sigma square, right? This is sigma square. Sigma will be square root of this, which is 80 by root n, right? So you just divide it by 80 by root n, right? To make it standard normal. So probability of mod x bar minus mu divided by 80 by root n. This thing less than equal to 40. This is equal to 0.99, right? Okay. So okay, you have to divide it by this thing here as well, right? To make the LHS and RHS value. Now, after doing this, this you can consider as your by using central limit theorem, you can call this your standard normal random variable, right? So this will become, so this implies this, and so approximately this thing will become what? Mod of z uh, less than equal to, so 42s are root 20, 42s are 80, and so this will become root n by 2, right? So also this was greater than equal to, right? So this thing is greater than equal to 0.99, where z is actually normal 0, 1. This thing is done. Now, so now you know that now you can use your table, right? So now you can use your table, the standard normal Gaussian integral table. And since this is mod, this will become 2 times phi of root n by 2 greater than equal Also you have to subtract 1 from it because the middle area has to go. This thing is greater than equal to 0.91. Okay, okay. And if this is the case, this implies that pi of root n by 2, this has to be greater than equal to what? 0.99 plus 1 by 2. This will become 1.99 by 2, which is 0.995, right? Okay. And if you use your standard normal the table, Gaussian integral table, this will tell you that root n by 2 has to be greater than equal to 2.58. This is using table, okay? And this implies that n has to be greater than equal to 2 into 2.58 whole square. This thing is equal to apparently 26.6256. So yeah, this is the answer. So let me know if something was not clear. I mean, this we have been solving these kind of problems for a while now because standard normal this thing has kept coming again and again. If it is not clear, let me know. Otherwise, I'll move forward. You just type it. Just type it, Google it, it will come. It's not tough. It's it's a it's available on internet actually. Okay. Uh, Okay, so from descriptive statistics, there are not a lot of tough questions. I will solve some easy problems. Descriptive statistics is actually quite easy. Third question. Maybe we will solve two more questions and then we will stop. So the fourth question is as follows. So you are given a list of data. Okay, 43, 37, 35, 30, 41, 23, 33, 31, 16, 21. Okay. The question that is asked is what is the mean? What is the mean of this thing? And what is the standard deviation? What is the standard deviation? So it's a simple question. So the mean, which is equal to mu, this will be what? Just you sum 43 plus 37 plus 35 plus 30 plus till 21 and you divide it by the number of terms. So how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10. Okay. And apparently this comes out to be 31. Okay. So if you have to calculate mean, just take the average. Your average is the mean. What about sigma? To calculate, say, you first calculate sigma square. For sigma square, what you do is you take 1 over 10 minus 1. So you take n minus 1. So the total number of data points minus 1. So total number of data points is 10. You subtract 1 from it. And then take this thing that you take xi minus mu whole square. Sum it over I equal to 1 to 10. Okay. So this will be like 1 over 9 into so the number is 43 and 31, right? So 43 minus 31 whole square plus 37 minus 31 whole square plus so on till last one is what? 21 minus 31 whole square. You calculate this. This comes out to be so I will just write the final answer, right? So if you do this, then sigma comes out to be 8.7551. Something like this. So a simple thing, right? Just calculate the average and the standard deviation, the mean and the variance. Take the So root of the variance, you get the standard deviation. There's nothing tough about this. Simple thing. Uh, okay. Next, we will solve one last question and then we will stop. A table is given to you. Okay. Uh, just a second. Yeah. Can you repeat the question? What? Okay. Okay. So is this question in your assignment or not? Okay. This is not from your assignment, right? Are you sure? Okay. Uh, okay. So okay, then I will solve this question only. I won't solve the other question that I was planning. So what is given to you? Uh, the thing that is given to you is that was there any question? So you are given that x1, x2 till xn. These are IID normal mu comma sigma square. Okay, and it is given to you that x bar is equal to 1 by n summation xi I equal to 1 to n, and s square is equal to 1 over n minus 1 summation I equal to 1 to n xi minus x bar square. Which one is not true? A option is root n x bar minus mu over sigma. This thing is normal 0 1, standard normal. B option is root n x bar minus mu by s. Okay. This thing is distributed according T distribution with n minus 1 degree of freedom. C option is variance of root n x bar minus mu over s. This thing goes to 2 as n goes to infinity. And the D option is root n x bar minus mu over s. This converges in distribution to normal 0 1. These are your questions, right? So the first two options are quite clear, right? These are just property of random normal variables. So, so if x1 till xn, if these are normal 0 1, then of course x bar will follow normal distribution. We just saw this thing, right? It will be 0 comma 1. I mean, okay, sorry. First of all, okay, let us do this. So what did we see? That we saw that x bar 1 by n summation xi. This will follow what? Normal distribution with mean 0. And what will be the variance or the standard deviation? That will be 1 by n. Okay. This much we know, right? Oh, this is mean. Okay, the mean is mu. Okay. The given mean is mu. So this thing is mu. This is sigma square. Sorry. So okay, if that is the case, then this thing will be distributed according to normal, mean mu, and variance sigma square by n. Okay, this much we know. So if you do x, so if you just subtract the mean and divide it by the standard deviation, right? This thing, what will this thing be? This will be distributed according to normal 0, 1. That's quite clear. Okay. Now, okay. Uh, and this the second thing is actually I remember this from a property that uh, if you instead of taking sigma, so okay, so like S square is an estimate of sigma, right? S square is like an estimate of sigma. It's of sigma square. So S is an estimate of sigma, and instead of sigma, if you use S, it will be distributed according to student T distribution. So root n x minus mu over S. This will be distributed according to student T distribution with degree of freedom n minus 1. This is actually a property that so if instead of the actual value of sigma, you use an estimate of sigma, which is S, then it will be distributed according to student's T distribution with degree of freedom n minus 1. And since this is the case, what is the variance of a student's T distribution? Root n times x bar minus mu by S. What will that be? So if n is the degree of freedom, the variance is n over n minus 2, right? However, the degree of freedom here is n minus 1. N minus 1 over n minus 1 minus 2. That will become what? N minus 1 over n minus 3, right? And this thing will, if I divide it by n, 1 by n, then 1 minus 3 by n. This is what it will become. And you take the limit n tending to infinity of this variance of this entire thing. This will be equal to limit n tending to infinity of 1 minus 1 by n over 1 minus 3 by n. Okay. What will this become? This limit, so this thing will become 0, this thing will become 0, this will become 1, right? So, uh, right? So I think what was the given option here? Okay, so this goes to, so this option is not correct. So B is correct, C is not correct, C is incorrect, right? Now, for the last statement, you need to remember this property of T distribution, right? So if X is distributed, X size are distributed according, no, let's take X is distributed according T of n, Tn, right? Uh, so simply if you take the limit n tending to infinity of a T distribution, student T distribution, this thing is actually equal to normal 0, 1. This is a property of your student T distribution that if you take the degree of freedom to be infinity, then it becomes a standard normal distribution. So since since this thing is already a student T distribution with parameter with degree of freedom n minus 1, and you take n to infinity, that means n minus 1 is going to infinity, and hence this thing is true. This thing is correct. So all of these things most in the whatever, what is the question? Is it asking for the incorrect answer or what? It is not true. Okay, so this is not true. The C option is not true. So variance is coming out to be 1 and it is given 2, right? Okay, okay, okay. Okay, this thing is given to be 1. Okay, okay, this thing is given to be 1 as in so this is correct. Oh, sorry. I thought I didn't say it correctly. So this is correct. So which option is wrong? Okay, so the B option is wrong. It's this thing is given to be n. Okay. This thing is given to be n. However, it should be n minus 1 because uh, root n x bar minus mu by s. will have n minus 1 degree of freedom, not n degree of freedom. The first option is correct and the last option is also correct. So B option is wrong. So B is incorrect. Sorry, I confused it. Okay. Okay. Uh, okay. So if so, that's I think that's enough for today. In case if you have any question, you can ask. Otherwise, we will stop here. Right. Okay. So okay. So maybe I'll just stop presenting. Okay. So thank you for joining. Have a nice day, and uh, see you in uh, see you in the next week problem solving session. Okay. Bye.